And that's what we want to do. We want to accommodate those males in drinking at their own level. Because if they drink too low, and they even drink downwards, they will activate the trigger pin, and as a result, your water falls down, and they have to chase that drop to ingest it, and they're not doing that. So that's why we say, raise the line for the males, and make sure that it is accommodated for them to drink at their own position. What we've seen as results, because that's what it's about, what pays the bill at the end of the day, is that with dedicated male drinker lines, you'll have much more consistency in your uniformity. So all the investment that you have done in rearing and producing these uniform males is sustained during the growing period. And that's where your benefit is. Because if you have uniform birds, male birds, you can also reduce the number of male birds that you have in your house.
More delivering eggs at day 19 of incubation. So the eggs actually, let's say, roughly in the same range as with the old chick. With actually a minimum level of ventilation, so you don't lose too much heat during that period of final hatch. So there will be an additional consumption of energy to maintain that temperature during these 2 days. But what we also see is that these chicks, because they have been spared from a lot of stresses on the hatchery, had this early nutrition, had that water availability, are more robust at day of hatch than a chick coming from the hatchery. So we see in the first week that we are able to reduce the temperature pattern in the barn quicker than with the traditional day-old chick. And then of course it will depend largely on the condition of the broiler barn and maybe the outside climate, how neutral at the end of the process it's going to be. But it's indeed something to look at. But the advantages in terms of better feed conversion and lower mortality, also on the carbon footprint, actually are overpassing, let's say, the disadvantage potentially with a little bit more heat during the house during these 2 days.
Thank you. And about the logistics, transporting 18 days chick, fragile?
Well, yeah, transporting day-old chicks is very fragile. Transporting eggs is fragile. So of course, we see that we are using the same type of trucks to transport 18-day warm eggs, as we call them. We use the same trucks that we use also to transport day-old chicks in the best climatological conditions. So the trucks don't need to be different, but they need to be adequate. And of course, the settings of the truck will be slightly different when it comes to eggs, as where it comes to chicks. But you can also put more eggs on a lorry than you can put day-old chicks on a lorry. So you have an advantage in terms of logistics. You have the possibility even to one same farm with different barns to in a single transport eggs incubated 17, 18 and 19 days. So in one single transport you can actually achieve 3 different hatching days on the farm. So there are a lot of advantages also for the logistics of a slaughterhouse who maybe has the desire to slaughter 6 days a week. But normally hatchery logistics only deliver chicks maybe 4 days a week. So with eggs you can also fit better into the logistics of a slaughterhouse. So it requires a little bit of different thinking than the traditionally hatchery way of thinking, but logistically there are a lot of advantages that you can achieve by choosing hatching on farm compared to traditional hatching on the traditional days.
If you allow me, a very difficult question, because you will see a shift of cost of energy if it comes down to the hatching period. So you lose 3 days in the hatchery, but you gain 2 to 3 days in the farm, but on lower temperatures. Have you ever made a calculation on what energy shift is there or what?
So instead of, cycle is 40 days, and then you have to add another 3 days. So it's also reducing the possibility of growing chicken around the year.
Yeah. So we have a lot of calculation tools actually showing what the cost saving benefits are. You are able, if you take all the different factors into consideration from investment to variable cost, you're actually able, when you hatch the chick on farm with the 2 or 3 extra final days, to produce a tail chick that at the end of the process will be cheaper than a chick produced in the hatchery, also taking into account energy. Of course, you do this in a model where you maybe start with a greenfield hatchery and you go and do it the most efficient way. But energy is definitely something to look into. And then secondly, your question. That's why indeed we tend more and more to deliver eggs at day 19, so that they spend 2 extra days on the farm. And we see, because of the advantages of early feeding and on-farm hatching, that during the growing cycle, let's say that will be between, so you start maybe with 2 days extra in a barn. At the end of the process, maybe still 1 day is lacking. That will be extra occupation of your house. You can see, do I take it away from my downtime or not? Do I have to shift my cycle? But you also have to understand that I think these are 2 very relevant questions that when we pitch this to prospects or convince customers, this is traditionally something we have to overcome. And I think these are the right questions where we spend a lot of time calculating and showing that the total picture indeed.
Vertical fermentation of manure, so it's composting of manure in a more efficient way, right? So within 7 days, you go from raw manure, which can be potentially, full of bacteria, of antimicrobial residues, of different non-desired elements that you want in your compost. So that's the part that is being done in 7 days. In terms of the smart, intelligent use in the system, it's fairly basic in a sense. It's just to control the level, the temperature, and the humidity level inside that big tank, right? Again, this is a natural process. What you want is, you want to promote aerobic fermentation. When you do the traditional manure piling system, you have aerobic and anaerobic, you have everything. Which means that also you have poor killing of bacteria that are present in the manure, mean also that you have much more greenhouse gas emissions. So if you want, it's a win-win on a number of elements. Safe manure to be used for farming, and also quick process, less emissions, less contamination of the environment, not just greenhouse gases, but also, I'm sure all of you have been in farm when the manure pile is outside and it's sort of, when it rains, whatever, the water leaks. And so if you have bacteria there, they're going to go into groundwater. So that's basically what the system is focusing on, is making sure you have efficient composting of manure, and also in a more efficient way to save groundwater, or to avoid contamination of groundwater with manure, raw manure, we know in terms of quality.
Thank you.
Sorry.